welcome. Good morning. My name is Erin, and along with Abu and Manas, we're going to be presenting our final project presentation, and we are group number 6. I'm going to start with our table of contents. We're going to go through the case introduction, analysis and decision-making process, our design phase, conceptual data modeling. We're going to go through the ER concepts in the assignment, going through questions Q.31 all the way to Q.832D, our strategies and feedback during this assignment, as well as our key takeaways. Starting with the case, as we saw in the book, in this case, we're going to be drawing an ER diagram to represent a sample of a customer order, which is for a furniture store. And then following that, we're going to, from points 8.32, A, B, C, and D, we're going to be going through a case study about a real estate property and how to connect the buyers to the properties, order numbers, and we're going to go more into detail for that and how we plan for it. Now we're gonna talk about an analysis and decision-making process. First, we needed to identify what were gonna be the main objects, the main identities, relationships, and cardinalities, as well as clarifying and making sure that we know what the information that the business needs and what the business needs for us to provide for them. And this is gonna be a need between, like a bridge for communication between engineers and business users. So once we build and design, we send it over to the engineers and they build it so that the end user is able to use it. And in this case, we're going to go through assumptions and choices. The assumptions are that there's unique contracts, phone and address for the offer, and we have choices, which are the weak entities for multiple contacts and enforced to contract links, which we're going to explain further with our diagrams. Now, going to our design phase. First, we need to have the forms of basics of logical database designs. We needed to reduce the data redundancy and improve performance, meaning that we didn't want anything repeated. We wanted to have all of the information very clear and synthesized for the end user to understand and quickly read. We wanted to simplify management by supporting a sustainable system. So we needed to build something that was usable, easy and comprehensible for the end user to use without any confusions, as well as any updates in the system will be very easy to perform. And the design needs to translate analysis into a robust database structure that is efficient, reliable, and again, maintainable. So the whole point for the design is for the end user to have a smooth transition with incorporating the system, using it, as well as maintaining and upgrading. Now we're going to talk about our conceptual data modeling. Conceptual data modeling uses ER diagrams to represent systems, converts business rules and data requirements into a visual blueprint that then the engineers can follow up. They have independent of any specific technology or database, meaning that these can be applied into any software, database, or any current programs and systems that the business is already using. It's easily transferable and flexible, serves as a communication bridge between business stakeholders and developers, just like we mentioned before, and ensures the final system reflects real business operations and data relationships, meaning that we're not adding any additional information that we don't need, and it reflects exactly what the business needs are. And now for ER concepts in the assignment, the ER modeling that we applied to maintain data integrity, minimize duplication, and ensure proper business rule enforcement, just like we mentioned before. We have a multi-value attributes handled by creating separate entities, just like you can see buyer underscore phone and buyer underscore address is some of the examples that we're going to be seeing in our designs in one of the further slides. Then we have to ensure each purchase offer links to a phone and an address. And we're going to be talking more about the one-to-mortar relationship in our modeling, and ending with business rules enforcement through relationships. Again, we're going to be touching more into that in the further slides.
Okay, so on this slide, I'm explaining the ERD question 3.1. So as you can see, we have 4 tables over here. So the order line table, order table, and customer table, and product table. You can see that how we can connect all 4 tables. So we highlighted one-to-many relationship. So one customer can have many orders, and one order can include many orders line, as you can see. And each order line references one product. So things like there's circle area where the primary key and the foreign key connect to each table. As you can see, so the foreign key over the order number, so that table can connect with the customer number, the foreign key with the customer table over here, the primary key is customer number. So yeah, and this structure helps to keep the data organized and prevent duplication. This also clearly show how customer drop flow and through the system from the customer to order to specific item they purchased. For the next one, I'm going to talk about 8.32a, the question number 8. So here you can see we have 2 tables, the property table and the purchase offer table. So I think the primary key for that table is product ID that is connected with the foreign key with the property ID. So this relationship is also same, it's a one-to-many relationship. That means that one property can have many purchase offer linked to it. but each purchase offer belongs to one property. The circle symbols one diagram helps identify this relationship visually. On the property side, we have one notation. One can purchase offer side, and many notation come to the foreign key. This setup ensures that every offer can be traced back the correct property, keeping the data constant. So here goes our another question, which is 8.32b. So here's also, as you can see, we have two tables, the property table and the purchase offer table. And we also connect these two tables with the primary key for property ID on that table, and for here foreign keys property table as well, because we have both same common table, this attribute over here, the property ID. So that's how we connect this table. So we highlight the property ID in both property table and the purchase table. And this concept is important because it prevents relationship error. If the primary key and foreign key don't match exactly with the two tables, then it won't connect properly. Then we'll not see the customer data and what they bought it and the price and everything. So it's very important to connect the table properly with the proper attributes. So the key message here, when building relationship, always make sure the primary key and the foreign keys align properly.
Okay, talking about the third portion of the question in this. The question speaks about how a customer can make multiple orders and how each order or each decision they make can be stored by the data in order to provide them a feedback or suggestions based on it. So as you can see, the major two entities we worked upon were the buyer phone and buyer address, as these store the information of the customer. Moreover, as you can see, like the buyer phone and the buyer phone has been connected to the buyer ID, which has been further connected to the buyer name. So it just gives an idea how a single customer has multiple portions to be taken care of, which the data can be derived from. In order to represent that, we have used multiple diamond signs, such as phone number, where he lives at, or the contract. So this ensures that all the data about one single customer is collected and stored at a single place, which can be further used to interpret the data, to analyze the data, and make a reasonable conclusion out of it. For the deep portion of this question, this one is much more detailed to that. As you can see, this one's about how different relationships about one customer or one buyer has been used in multiple aspects and has been connected to the buyer. For example, the buyer entity, the buyer name has been connected to the purchase offer, to the buyer address, which has been further connected to the offer contract and the address. So these separate entities prevent data duplication and improves data consistency. It is much easier to maintain lots of information about a single customer at a stored place, which makes it much easier for the engineers or to the designers for the next further round. So the strategies and feedback we use for the course, first would be the strategy would be, we then break out into a small groups where each individual had a rough sketch, and then we further presented it to each other in a way and came to a conclusion what could be made the best use out of, or what's the best solution to the question. We use the layered approach. By this I mean we relied on relationships, entities, and the keys. And at last we used the reverse rule explanation. This means that after completing the whole draft, we went back from the end to the first just to see if the whole process is reasonable or is applicable in the real world. The feedback for the assignment is, on behalf of the group, we would say this whole assignment gave us an idea how a system design phase works, starting from the rough diagrams to the passing on to the engineers. This of course helped us in the teamwork and problem solving. In a way, it was a whole summary of the course we learned so far in the 4 months. And again, the diagrams and the attributes, the relationships, and the entities represented the full system design analysis.
Okay, so wrap our presentation. So we have 4 key takeaways. So the first one is, so the ER diagram serve as documentation for long-term system. So yeah, so for things like, so for long-term, the process for the business analysts and everything in future. So the long-term, so the ER diagram serve as a documentation. So everything has to be correct. And the second one, the unclear information can cause future issue, which is true. So in some cases, so if the diagram and the data is not stored properly or not connected properly, then it can cause a lot of issues. Then the whole system needs to be rebuilt, and then again, it has a lot of work and a lot of money as well. So the third is handling the repeated data often require creating new structure. So the thing is, like in the business, there's a lot of data that we store that's repeated, and like for example, it's the same data that's come over again. And then for that one, actually, we need to build something that's alternative, the new structure. So those repetitive data should be stored in that way. And the last one is the clear ER diagrams are crucial for long-term system reliability and careful management of the complex data essential. So after like all the data and stored, so the ER diagram has to be very clear. If the data is not clear, so that would be a lot of problem for the long term in the business. And also, if the ER diagram is more clear and is managed well, then it will be easy for update, manage, and in other complex data is essential. So thank you everyone for listening to our presentation. Hopefully you like it. Thank you.
Thank you.